This work presents OSMa-Bench, a benchmarking pipeline designed to evaluate open semantic mapping methods. The methods are tested on generated sequences using a pipeline that evaluates semantic segmentation and scene graph quality. We compare 3D reconstructions with predicted semantics and use LLM-generated question and answer sets to assess scene understanding based on build graphs. The process begins with test dataset selection. We used photorealistic habitat Matterport 3D and synthetic replica CAD. To evaluate robustness, we generated test sequences with varying lightning and agent velocities using JSON files. Also, we randomly selected trajectory points. This automated approach enables the generation of 24 HM3D and 110 replica CAD sequences. We noticed that the standard replica CAD dataset lacks some semantic annotations. To enhance evaluation accuracy, we extended the dataset with a more comprehensive ground truth segmentation. Finally, for HM3D, we compare following setups: nominal lights with default scene illumination, and camera lights, where we mounted a directional light source next to the camera. For replica CAD, we added two more setups: baseline with predefined set of light sources, and dynamic lights with changing illumination along the agent's path. Additionally, we introduced a velocity variation for both datasets by doubling the agent's movement speed to evaluate its impact on the quality of semantic mapping. Conducting the experiment and getting metrics of mean accuracy and frequency-weighted mean intersection over union, we reveal specific issues caused by lighting variations, including segmentation errors due to illumination changes, loss of small objects during reconstruction, noisy point clouds, misclassifications of shadows as objects. To evaluate semantic understanding, we developed the visual question-answer model. We first extract keyframes along a trajectory. These frames are then processed by LLM, which generates a structured description of each scene in a predefined format. Once the scene descriptions are generated, we create a structured set of question-answer pairs for different questions categories. To ensure question quality, we perform validation, eliminating duplicate questions, ambiguous questions, and questions which lack sufficient visual information for a definitive answer. The validated question-answer pairs assess semantic mapping quality by comparing LLM-generated answers from the evaluated scene graph with ground truth responses. We tested two state-of-the-art methods, BBQ and concept graphs. The results highlight differences in performance across question categories. Main observations are that object relations remain the most challenging category. Attribute-based questions often fail due to missing material and property details in scene graph captions. Also, we identify object merging errors across both pipelines. For example, using measurement type questions, we detect that each stair step is counted as a separate staircase.